If you haven't been with us before, this is the fourth in a series of Tech Tip Thursdays for Delphi. We've done EVAP system operation, we've done monitors, service bay tests, and now we're going to finish up with testing the EVAP system. Getting down to basics. If you can apply this, the EVAP system will become much easier for you to work with. But before you do it, you need to understand what's going on with the different systems. And let's get show on the road. For you that don't know me, I'm Rick Escalambre. I've been in the industry 52 years. I ran the automotive program at Skyline College in San Bruno, California. I have made EVAP a specialty since 2005. Put many hours in it and trained over 6,000, almost 7,000 people in EVAP. So hopefully we give you something solid to take away today that you can use in your shop immediately. And most of this is just good common sense. Okay, what are we going to do in this next hour? Before blowing smoke in the system, well, we're going to blow smoke in the system today. We need to understand the different size leaks, how big they really are, how small they really are. There's a thing that I love to call sequence of events. That's how things happen, the order in which things take place. And that's the same thing you're going to want to do in your EVAP diagnostics. You're going to want to follow a plan. Don't be hasty. And include in it, number 3, your visual inspection. Always do that, especially for some of you that are used to the Rockies. You have to deal with rust and other things like that. Where in California, where I'm at, we don't have to deal with that as much, but it should be part of your standard testing. Then this time we're going to get into using the smoke machine, proper use of it, precautions you should do, some safety that you should be aware of. But in reality, it's a wonderful machine, but it doesn't do everything. It can hide some problems and it can miss some problems. And the last thing we'll do is look at methods for looking at the leaks. Okay. Starting out, I don't know how many of you have been with me before, but this is my website. It's free. It's a resource for you, the technician, instructors that are out there, industry trainers. Doesn't matter. It's a free resource for you. After 52 years of this industry, I decided it was time to put a resource up there with no cookies, no advertising, that technicians can use as a go-to place for not all the answers, but for a lot of information. And I'll be adding more this winter. It's been a busy summer and a busy fall, so I'll be adding a lot more content to this website. So please feel free to use it, and also feel free to contact me through it. I respond whenever, as quick as I can. If you have questions, I'm here to help you. I retired from the college 10 years ago. I could have walked away from the industry, but this industry's been good to me for so long. I want to give back to you that are still in this industry and help you where I can. So again, feel free to use this website. Give me any feedback on it. And one important thing is up here, there's a thing that says new content. What's important about that is if you've been to my website before and you've gone to websites before, you go back and you wonder what's been updated. Well, that particular page is like a TSV page, and it will list the most current things that I've listed. Maybe you can look at the date and say, well, that's the last time I was in there. This is what Rick's added. So I find that very helpful, and so people respond to me saying that was very helpful for returning to the site. And that's what we want you to do. It's not a one-time look and see and forget it. It's a get in there, use it, use it as a reference, and there'll be more content coming. Okay, EVAP system leaks. Let's take a look at the fundamentals of that. First of all, since 1998, and there's some that did this before, 96, 97, full systems, they were required to find a leak, as I could say, as large as 40 thousandths of an inch. I could say as small as 40 thousandths of an inch. It's how you want to look at it. By 2000, all vehicles had an enhanced system capable of detecting a very small leak as little as 20 thousandths of an inch. The rule of thumb for a large leak is it's larger than 90 thousandths of an inch. So keep that in mind. It doesn't have to be a cap-off type thing. It can be a hole in a plastic line. It could be a diaphragm that's ruptured and sucking air. So think about that. The important part to remember in this, if you want to know if you're working on an enhanced system prior to 98, is look at the EVAP readiness flag monitor status. If there's a EVAP monitor in there, then it's a once per trip monitor. That means you have a full testing system. Okay, and then also remember, we discussed this in the last class a little bit, you do have service bay diagnostics on some of your scan tools for your aftermarket. For the OE, if they have it, they'll get it. In the aftermarket, you have to be careful because it doesn't mean they always work. They might offer it, but it may not follow through. So just keep that in mind, but please put that on your list of things to look for on the OEM side of your scan tool, your Snap-on, your Autel, whatever it might be. Go to that side of the scanner, go into active tests or special tests and see if there's an EVAP service bay test, and follow the instructions in there very carefully, and see if the car does run the test for you. It may not flip the flag, but if it runs a test, that's proof that there's no leaks. Okay, EVAP size, just for comparison. I just kind of blown the slide up to show you how small a 20,000 of an inch leak is compared to a dime. More importantly on this whole thing is it can be multiple leaks adding up to 20,000 of an inch leak. So you can't just say, oh, there's one spot. It could be multiple. And they can be very small. It can be very hairline cracks. I'll show you at the end. 40,000 of an inch compared to a nickel, a little bit bigger. The key to this is really the volume. You can see if you get into a 40 and you double that and go into a 90, you can see the amount of leakage, the amount of hydrocarbon vapor being emitted into the atmosphere. Where the 20,000 of an inch is smaller. And I want you to keep that in mind when you're doing your testing, because the smaller the leak, we may need to reduce our flow into the system because we may actually plug the leak in some cases. So we'll get into that as we go along. But I just want to give you a comparison how when you're working with leaks, what you're actually dealing with. Okay, now I like to do this thing. Every time I teach, I like to do a thing called, I'm going to turn this off. Let me get this off the screen. I like to do a thing called sequence of events. And it's a logical way of thinking for technician. I don't care if it's ignition system, fuel system, computer system, EVAP system. I use this term. And it's simply put in this case is what brought the customer into the shop. Well, with an EVAP problem, they're not coming in unless they have a mill on. Okay, or they're having a hard to fill vehicle. What's the first clue of the customer's concern? Obviously is the mill is on and there's a DTC present. And what I like to look at is what sequence of events did the PCM follow to lead the customer to your shop? Well, first thing is, remember, since the mill's illuminated, that means something happened. It means one or multiple monitor tests completed testing. Completed means done testing. Completion, there's going to be a result. If it completes and it passes, you're done. No mill, you're on your way. If it fails, then there's going to be a DTC with it, and there should be a mill on. We need to be careful, though. Some of the EVAP DTCs are 2-trip codes, so after you run a test, you may want to go in and take a look at your pending codes on the global side and make sure it didn't fail the first trip. Anytime you're looking and you run in a car and you're not sure if it's set a DTC, don't go just by the mill. Go look at a pending DTC. It may not be a confirmed code, which means you shouldn't be replacing anything yet, but it's a clue that something is not right and it needs to fail one more time to turn the mill on. Okay, once you get there, if it's a DTC EVAP problem, what do you do next? And this is my rule, and I mean this sincerely to you out there working in the industry. Do not touch anything. You're getting paid. You're going to probably charge a flat rate diagnostic fee for the EVAP system. I would do that if I were you. If you touch anything, as simple as turning the cap, you might already fix the problem and you don't know it, but you still need to go through and test it to verify it. So with EVAP, you charge your diagnostic rate, whatever it might be. Most people tell you should allow an hour if you're going to get into the system and do it properly. May you find it quicker? Yeah, but that's the beauty of having the skill to do this. But by not touching anything, you test it as received, go look for the problem, and we're going to take you through that process. Okay, first of all, always do a good visual inspection. Look for loosely fitting hoses, clamps, rust, any signs the system could have been damaged or in an accident even. Look for crack lines. Some of the systems use plastic lines, and over time they age, they crack. We all know there's rodents in the engine compartments and under the cars, and they like rubber vacuum lines and hoses. So do a good visual inspection. Make sure you look at your components that are easily accessible, and that means take a look at the connectors, take a look at the hoses, take a look at the fit. Make sure somebody hasn't been in there touching it. Make sure something isn't cracked. Now, if we get into Japanese cars, Toyota and Honda specifically, there's a bypass valve, usually located under the car. Not as easy to see, but we'll show you a picture of why you might want to go ahead and inspect that. The vent solenoid sometimes can be easy to see, sometimes it's not. It can be subjected to rust, it can be subjected to laziness. And what I mean by that is, especially for you people in the colder time zones, that vent solenoid could sit around all winter, never being moved. And if never being moved, first few times it's going to be operated after a winter, it could be sticky. It may not even move. And it could be setting some leak codes. So it's something we need to talk about and be aware of, because you'll be chasing a problem for a leak that you don't have. always check your FTP, your fuel tank pressure sensor, or for the systems like Chrysler, BMW, and there's a couple others out there that use switches. Verify what I call the reporting component, and you can do that with your scan tool, is operational. Is it normal reading? We're going to take a look at that as we go through this. You may also hear it called, in some, especially some of the Korean cars, you may hear them called differential pressure switches. They're the same thing. What it means is one side of the diaphragm is open to atmosphere and the other side is open to manifold vacuum, and the differential is a vacuum. So don't get lost in terminology, but that's the most important component in the EVAP system, is verify that the reporting component actually works. And we'll get into that a little bit more through the presentation. Here's an example of solenoids underneath the cars, and hopefully you in the Eastern time zone, you probably Midwest, you kind of chuckle at this because this is a normal occurrence in some cases. Out here, unless you live by the ocean where the salt air is, you're probably not going to experience this at all. We don't have road salts out here or anything like that, but something to look at as you're doing it. Good visual inspection is the first step of a diagnostic plan. Here's another one where the vehicle had been worked on previously. They didn't put everything back where it belonged. This is a vapor separator canister on a BMW. And you can see shoddy workmanship led to a problem. In an upper right-hand corner here, you can see eventually this thing rubbed away, created a small leak, and waste time and money. So it's very important that you look at how things are. Even if you've got to take pictures of them before you take them apart, just make sure you put them back the way they were. And to show you what poor workmanship this was, this is an 18 millimeter snap-on wrench that somehow when they lowered the chassis, the suspension I should say, when they lowered that, they put it back in and they left a wrench in there and they pinched it. So poor workmanship leads to problems that we don't really need to have. Another one, always check this. When you have a flow problem, you have any kind of restrictions, always check the purge solenoid for signs of charcoal. When the charcoal canisters break up, that gets into the system. I'll show you an example at the end, what problems this can cause. But the main thing here is shake it out, check it out, blow through it, make sure there's nothing in inhibiting it. And if the canister is accessible, tap on it or take it off and rattle it. Just see if you can get any shaking out of it and the canister's breaking up. They're spring loaded. They adjust different size for different engines, different amount of size tanks. So there's some airspace in there, but they're all spring loaded so that they hold the tension on the charcoal canister, granulated charcoal where they're doing this. So good in visual inspection. One other thing, this has been pretty much eliminated on most cars the way they're located today with the vents, but there's still some, but older cars were more susceptible, especially off-road vehicles, to picking this up, because remember this, the vent into the EVAP system is like a vacuum pump. When that thing is breathing and that thing is sucking, if there's anything in the area, including water, you might even be backing a boat into the river to launch it, and you get that vent down into the water, you're going to be sucking water or sand into this system. So these are good preliminary checks to know what kind of vehicle it is, how it's been driven, and what should you be looking for. This is another famous one for a long time. Cobwebs, spiders love heat. And when you fill up your car and you're putting fuel into the tank, that vapor that goes into the canister is actually heating the canister up. Because of that, over time, that thing becomes susceptible to spiders trying to get in there. You get a vent code problem and you got a tube hanging down, take a look at it, make sure it's clear. Make sure something hasn't crawled in there, made a home, created a nest, and that's what your restriction is. So good visual inspections on these systems. These are little tidbits that over the 20 plus years of EVAP systems that you need to take a look at. It's not a simple checklist to go to. It's something you acquire through experience or from hopefully taking webinars like this. Okay, testing the system overall is pretty straightforward, but there's a couple things I want to go through before we go any further. One of them is safety. You are working with fuel. You are working with air, and all you need to start a fire is a spark there. So when if you put air into the EVAP system and you have a leak, you're creating a wick to the outside. If there's a spark in a nearby area, it can ignite. And when I say ignite, it can light, get into the tank and create a fire. I'll show you an example what happens if it gets into a closed system and there's a spark. It'd be just like a combustion chamber. But do be aware that there is some safety issues involved in this. And if you did a Google search, you'd find out that there's a couple incidences around the country, and in Canada there was, where shops were burned down because of EVAP fires. The vapors got outside, there was a spark, and bang, there was the start of a major fire. So all we need is a source of ignition when we're working with EVAP. Now, the conditions that could cause that, well, if you take a look at fill up, the main vapor related area that could create an issue is right at the filler neck. But as the level starts to drop, now it moves into the tank. Okay, it moves into the tank even more. Now we're at about a 50% level. You can see there's vapor. And I want you to remember this for testing too. We definitely want vapor space in there when we're going to smoke test, because if it's all liquid, we may not see the leak with the smoke for one. And in some cases, it can actually seal the leak by using pressure. Now, if we get down to a very empty tank, you can see how much vapor is in there depending on the outside temperature. You could have a fire right there. And in this next example, I'll show you what happens if you ignite an EVAP system or a tank with a sealed tank. So let's take a look. Okay, so just a reminder before we proceed that safety should be an issue with EVAP. Don't take anything for granted. You are working with fuel, air, and possible spark. So common sense goes a long ways. Okay, the ORVR system for vapor recovery. I want you to be aware of this. It's something that's not talked about much. It's not even something that's thought about much. But when there are issues with this system, the number one thing is it won't fill up properly. And we're going to take a look at this animation from Hyundai that's been out for quite a while. And this is in the late 90s they showed this system, but it's still relevant today. So let's take a look and walk through this system and discuss how this is going to work. So we go to the ORVR system. It's basically for recovering a vapor. We don't want vapors going to the atmosphere because that's money. That's hydrocarbons. That's defeating the purpose of emission systems, and it's costing us more money. So we're going to go through each of these systems and look at some of the components. You can see here what some of them are. We're going to pull it all together here in a minute. And here's an example when you fill up. What you're doing is pushing air, hopefully air only, up through the fuel shutoff, into the liquid separator, down into the canister, and out to the fresh air. So we'll look at this again, but there's a process there that's very, very important. It's right here at the liquid vapor separator. I want to pause it here for a second, because if you're the type or you have customers that do this, they like to top it off. My rule of thumb is first click, I'm done. If you keep clicking it, what you do is you increase the level of fuel in this vapor separator. And if it starts going over the top, it gets into the canister and it begins to destroy the granulated charcoal that's porous in there, and it turns it into mud. That can become a restriction in the system, and we'll show you again at the end of a case study. So the liquid vapor separator, everybody has one. They're located in different places in the car. Some are higher, some are a little lower. The ones that are much higher, it's hard to overfill those and do that. But the ones that are lower in the system, they can create a problem. Next thing you got liquid fuel dripping out of the canister. Chances are that canister is now toast. But this liquid vapor separator is to let the vapor go up and the droplets of fuel to go back. Okay? So very important that we visualize this when we're testing the system. Okay? And it could also be a source of a leak too. So smoke is important. Now, as we fill up the canister, this is porous granulated charcoal. Thousands and thousands of pores in it that absorb the hydrocarbons and vent the fresh air to the atmosphere. This is going on. As this process is going on, that canister is getting warm. Now let's take a look at the system again in operation. We fill it up. We go up through the fuel shutoff valve. Only air should be going up through there. Okay, then it goes through the liquid vapor separator down into the charcoal canister. So here's the overall picture operating. Fill it up, send the vapors up, drop the fuel back to the fuel system, let the charcoal canister absorb the vapor, and let the fresh air go out of the system. This is ongoing. Again, the most common symptom with this is hard to fill, and or you could get into restriction because the canister itself has been blocked and the vapor pressure is drawn down too fast. Okay? Now, I like to use the word perform driver seat diagnostics. Identify the DTC and what is normal. Okay, and first of all, I always start out with this. I've done this in the other webinars. always start out with EVAP. Always check your FTP or your switch or your motor, depending on what the reporting component is in the car. So I mentioned earlier that the pressure differential sensor is a sensor that measures barometric pressure and tank pressure. The difference between the two of them is a vacuum, and that's what we're working off of. Where the other systems, we're using a switch to move that changes status with a diaphragm, and we use a motor that basically changes amperage draw with speed. If you look at this lower right-hand corner here, you'll see that on this DRB3 checking a leak detection pump, the very first test they do is the switch. If the switch doesn't pass, they don't do any more of these tests. Unfortunately, on this system, if they're not working right, they will believe, especially on this system here, they'll believe whatever the FTP is telling them, and they won't say, "Oh, this FTP's got a problem," unless it's an open or shorted circuit. It's going to set a code for those, but it's going to use that number to do its testing from. And that's why I say to you, always check the FTP. And one simple check you can do is get it in closed loop with your scanner hooked up, take it up to about 2,000 RPM, and hold it there for a minute and see if you're starting to draw a vacuum in the tank. Look at your FTP, see if it's starting to drop. If it is, that tells you two things. One, the purge is opening up, the FTP is moving, and chances are the canister is there, it's in place, its integrity is still good because it is a partial restriction, so you are drawing some vacuum. Okay, if it's not changing, it could be the purge isn't open, it could be that you have a large leak, it could be that you have a bad FTP. Before you pull out the smoke machines and do what we're going to do later, make sure that you check this before moving on. And what that means is you also need to know normal voltages for the car you're on. Now, a good rule of thumb is most cars, 2.5 is the norm for atmosphere. Anything below it is a vacuum, anything above it is a pressure. GM decided to flip a couple wires in their harness and call it still call it an FTP, but normal voltage for them is 1.5 volts at sea level. The difference with them is up is vacuum and down is pressure. And there were a couple of Hyundais in the 90s and early 2000s that used the same system, so you might see the same thing on theirs. The only one in the marketplace predominantly is GM, with a couple Hyundais that use the GM system early on. As far as the Japanese cars, you can see Toyota's 3.3 on their older systems. Then they went up to 4.1 on their pump systems. And if you notice, Nissan uses too. So by me looking at the voltages, I can tell right away what system I'm on, especially these middle years. Okay, so it's good to know normal. The way I like to explain it is, if you're having a slow day and there's a car sitting there that's in good shape and you got some time, take that scanner out to that car and start looking at some of this stuff and determine what normal is. It can save you a lot of time in the future. Okay, verify the reporting component. That's the FTP or switch in most cases. Understand normal system voltage when it's open to atmosphere. Does the FTP change with vacuum as the engine purge is duty cycled? Does the reed switch close and open properly? And some of these you can just see that by applying vacuum to the system. Okay. Now, when you do the FTP, make sure you inspect the connectors, terminals, make sure they're tight, make sure nothing's been stressed and pulled. You can see on the right-hand side, a typical fuel tank pressure sensor is a 3-wire sensor with 5 volts on terminal 3 in this case. Ground is 2, and your variable signal back to the computer is on pin 1. I always say this, find yourself a good ground, back probe each of those wires. You don't need a schematic to do it. You're going to hit a 5 volt on one, you're going to hit about 0.2 of a volt on another one, and the one that's got somewhere in that 2.5 volt, 3 volt range, whatever it might be, that's the key wire. That's the one you back probe. Okay, very simple as that. And then make sure you run it through the checks and making sure vacuum goes up, vacuum goes down, pressure goes up. And if there's a problem, what usually happens is the vent side of it gets plugged and the diaphragm gets stuck in one position. Okay. As far as system components, the purge and the vent are our main 2 solenoids. We also have on our Japanese cars a bypass solenoid underneath. The main thing you want to do is you want to use your scan tool to be able to activate these. The purge, we're going to get into that in the next slide. The purge can be duty cycled 2 cases. Some will duty cycle with the engine off. Some will I cycle them with the engine on. You need to know that because it's nice if you can do it with it running, but if the manufacturer doesn't let you do it, then you can't do it. The canister close valve or the vent, that is either an on or off, and that's the one when you're activating it. Not only you want to listen and feel for a movement, but you want to do it multiple times because it may get stuck, you might get lazy, and by working it, you may free it up. Okay, so anyway, on both of them, check it multiple times. Purge is easy because it's constantly duty cycled, so it's moving. But the vent is not, so it's important that you do both. Now, when you go to this testing, you can't do this on global OBD2. You must go to OEM because the OEM is going to decide what tests they're going to allow you to do. Are they going to allow you to do these tests running? Or are they going to allow you to do them key on engine off? So make sure you look at the manufacturer specific side, and you'll usually find them under active tests or special tests. We used to use the word bidirectional, but what I see on most scanners now is active and special test. Most of the cars, again, will either do a key on engine off or key on engine running, but they won't let you do the two together. GM has always been the one of all the systems that will allow you to do what they call purge and seal. They will manually close the vent, allow you to open the purge, draw it down. If you draw it down too much, it'll suspend the test so you don't collapse anything in there. But you can pull it down to a vacuum, lock it, and see if the system holds on its own. It's not the same as doing the main test that the PCM would do, but it gives you an indication if the system is tight. So again, know your scan tool. Know that you have to go to the OEM side of the scan tool to do this work. Hondas, we know in the early ones, there were 3 solenoids, just like the Toyotas. Generally, the Toyotas only allowed you to operate them individually. With Honda, you could operate one, you could operate multiple. So that would give you a little more latitude in your testing. So look at the car you're working on, figure it out, and you'll see how to do it from the driver's seat to be able to seal the system. As far as the components itself, whether it's a purge or a vent, they all have coils in them. They all have resistance values. Typically about 68 degrees Fahrenheit is what the spec comes with. And if they don't give you a spec as far as plus or minus, so let's say it's 45 ohms. I like to use the rule for temperature change of 35 to 55 as a range. And that's stretching a little bit, but that's an indication right there. But I want you to remember on the solenoids is just because they pass the ohm test doesn't mean when it gets hot it's going to work. Think of it like a fuel injector or a coil. Generally, if you're doing your due diligence and testing, you're scoping it for a pattern, but you're also scoping amperage to see that it actually is moving the pintle the way it should. So I'm going to pull up this little injector pattern here, but it could be any coil. And basically at number 1, we're going to pull it down. We're going to ground it. We want to make sure that we're getting full movement of that pintle. So when we turn the coil off, we get a spike. And when it finally seats itself, we get a little reverse direction here. Now, you could, if you want to get into the wires, you could put a current probe on this and see that it is ramping up properly. But remember, solenoids can stick. If they don't open 100%, especially the purge, then you're going to have a leak code because it's not pulling down deep enough into a vacuum when it's commanded open. If it's not open at all, obviously you're going to have a large leak code because there's no change. The vent is the same way. If it isn't seating all the way, you're going to have intermittent leaks. So make sure that you realize you're working with a coil, and you could do current ramping, you could do scoping of it if it's in question. I'm not telling you to do this first, but if you have an unusual problem before changing a part, you might want to scope it real quick to see if the pattern looks something like this. Okay? And again, here's some other rules, especially with the vent solenoid. Vent solenoids, I said to you, they're lazy. They sit around all winter. They get sticky. You need to work them. If you're going to ohm them, remember, look at the spec. And typically about 68 degrees Fahrenheit is where the spec is given for. So it's nice to know the temperature. And if you need to, you can manually ground the correct wire to operate it yourself. And while you're grounding, you could read the amperage draw. And typically they're going to come in about 200 milliamps. And I'm going to emphasize as we go through this, and I'm going to emphasize on this next slide, is make sure you don't hold the ground on these too long. Because while you're flowing current through that little coil, you are overheating it if you leave it on there too long. And we're going to show you that in mode 8, where the PCM turns the solenoid on, sometimes it can be forgotten about. Next thing you know, 10, 15 minutes later, you realize the key's still on, and that solenoid has been grounded all that time, and you may cook it. And you may not get an instant response is that it's bad. But 2 or 3 or 4 or 5 weeks down the road, the car comes back with a bad vent solenoid, and everybody's wondering why. Well, you could have damaged it right there by leaving it on too long. So think about that when you're doing your work. Now, a little chart to diagnostic plan to EVAP and leaks. One, the only reason you're doing this, there's a mill on. Nobody's going to come to you and say, I want my EVAP system checked. It's a mill that's driving them. Two, verify what kind of DTC you have. Do you have an electrical issue? Do you have a performance issue as far as leak? You should separate those. I would go after the electrical first, go after the leak second if you should have both. Don't forget TSBs. They've really calmed down. The systems have gotten so much better, so much more reliable. But you should do a quick TSB search to make sure you're not missing something, and make sure that any existing TSBs haven't been applied to the system. And then if there's a diagnostic chart, or we just call it trouble tree, take a look at that to help you out. Isolate the leak by properly preparing the system. We're going to go through that. Confirm the leak is present by using an EVAP tester, and we're going to talk about nitrogen. Even though it's not commonly used, it is recommended. We'll talk about why. Locate the leak with smoke and a white light. You can also use, I put an or because you can use sound. You can use spray bottle. You can use a number of things with soapy water to find that leak. Okay, and I'll show you a sniffer you can use. Pinpoint it using a UV dye in the concentration that's in your machine. An ultraviolet light is very helpful, and some of them sell yellow goggles to go with it because it helps you to see the light better, the ultraviolet light better. So do you need it? Not always. Well, again, we'll talk about that. Make sure you repair it and retest the system. Now, it may not be practical for you to go out and run all the monitor tests, but I do want to make sure that when you do it in your bay, that you follow these procedures closely, and when you get done, you'll know that you were close, very close. The monitor tests allow the PCM to tell you that, yes, you've done everything right. Now, can it pass and still fail later? Yeah, you could have some borderline situations, and depending on conditions, it could pass and fail. But as a whole, you can manually test the system and get a pretty good idea. Okay, as far as a smoke machine, there's all kinds out there. Whatever fits your budget. You can even get little ones now for $200 from, they believe it's Autoline. They got a nice little unit. It's got a flow gauge on it, and it does a great job of blowing smoke. Remember, all these smokes machines are limited to about a half a PSI. That's it. That's all you should ever put in the EVAP system, and that's what all the machines are regulated to. But if you're going to set up a cart, just say this cart right here, you got an EVAP tester, you got a bottle of nitrogen. Again, that's a personal choice I make. I'd rather see nitrogen going in there than air. It's an inert gas. It can't ignite. But if it's not available, and I'll be honest with you, I've tested plenty of vehicles without nitrogen. It just means be using a little more common sense so there's no accidental fires as you're working on this thing. It's all due diligence. If you don't use nitrogen and something happens, then you could be held liable by the consumer. They got the car burned up. Maybe you're renting a shop and you burned it down if the fire was bad enough. But nitrogen is just a simple way of doing it. A little bottle attached to your cart, it will do everything you need. So it says here, 2 rules to follow when deciding what to use. What are acceptable business practices and standards? And what is the vehicle manufacturer recommended procedure? If you're following those 2, then the liability is lessened on you. So you decide what to use, but I'm just letting you know. Now, as far as the smoke machines, what I say to you is, I'm not telling you to take the arrow on the left there and take it and rip it off the machine. You can still do a calibration check as a guide, but please do not use the red arrow as a pass-fail. That would be the biggest mistake you're going to make. And what I want you to remember on EVAP is the car does not leave the shop unless the ball is all the way at the bottom and is staying there when pressure or smoke are being applied. If it's anything other than that, you got to go find it. Don't say it's below the arrow. Below the arrow means the system is technically passing, but as we're going to show you on this next slide, here's a vehicle we had. It was a Nissan we had, and it kept throwing a code. And it kept throwing a small leak code. And if you look at the gauge where it's set for 40, it was tripping a code 30 thousandths of an inch, okay, or basically 3 liters of flow. Not at the bottom, not over the line. So again, my advice to you is the red arrow is a guide, but if it's not at the bottom, you're not happy because you're going to have that coming back to you. Okay. Now, as far as accessing the system, Schrader valves were around for, early systems, 96. You could get them as early as 96 on some. About 2005, 6, 7 in there, they started disappearing. Now, I can't say I've looked at every vehicle, but to my knowledge, they're pretty much history. One, it's an additional cost. Two, it can be a source of a leak too. It has a Schrader valve in it. And it seems like some manufacturers decided the cost and the access there was not as important. But when you have it, you have these adapters. And always remember, if you go in there and you do what I'm doing here, it's recommended that you take the valve core out first before you start applying any of this system. And remember, this is important. The Schrader valve in there is a left-hand thread. So it comes out the opposite way that you would normally take it out. So when you're tightening it, you think you're tightening it, you're actually removing it. So very, very important. But I like to remove it because if I'm going to test the system, I don't want any restrictions at that point. So it's a good rule of thumb. Now, what if you don't have a service port, which a lot of cars don't nowadays? I don't recommend taking off the gas cap and putting one of those rubber cups over it and smoking through the back there. Because one, when you went back to the gas cap, you have literally removed a component that could be leaking. Where if you do this, the chances of that being a leak, you could even leak test it first if you wanted to. You could spray it around there when it was drawing vacuum, see if anything happened. But what I recommend is if it's accessible and you can do it, you can remove it there, you can apply it there. Now you know you're testing everything in the system except for this is a vapor management valve from a Ford. Everybody else calls them a purge solenoid. There's differences, but for right now, this is the way you can apply it and get yourself into the system to isolate everything except the purge solenoid. Good little trick that works. If you need to test the purge, you can go the other way. Now, I think you can figure this one out even without putting smoke in there. You could blow through it, and you'd be able to tell if it was or wasn't working. Okay. How about closing the vent or the back door? That is the key to sealing the system, perform the test we want. There's a few methods to do it. One is to let the generic scan tool do it, mode 8. The problem with that is it does not work on all cars. When it works well. One thing I want to mention on mode 8 is generic, and this is important. It only grounds the solenoid once per key cycle. It does not release the ground when you exit the test. I'll show you that on the next slide. Look at your OE side and see what kind of active or functional tests they provide you for checking the purge, the vent, possibly the middle solenoid, the bypass. Do they allow you to combine them? Get into the OE side of the scanner and see what they do. If you want to close the vent, you could manually ground it by getting the ground side of the circuit, applying ground to the frame, and holding it for a period of time. But just remember what I said, you don't hold it too long. The problem with that is you are bypassing the PCM, but unfortunately, on some of our scanners, they don't always make the vent solenoid easily accessible or accessible. And remember, you'll never find a vent side solenoid control on the global side of the scan tool. I don't know why they didn't include that, but they didn't, and it's a shame because it would have made EVAP testing a lot easier. Okay, and you could use pinch-off pliers to isolate the system, and I'll show you how you can isolate it through the fresh air tube on the canister. But when you're using pliers, you always want to ask yourself, where did I place it in the system, and what did I bypass? And what's ahead? What's behind? If I move it forward in the car, towards closer to the smoke, and the problem stops, then I know I'm good between there and the smoke. I want to go back to where I was last to see where my leak might be. Okay, so when you do mode 8, here's the thing. It says evaporative system leak test. It says system test successful. Got to emphasize on this. It is not necessarily successful that it sealed the system. What it's telling you is it grounded the solenoid. The solenoid should be grounded so you can do your smoke test. So what I recommend is apply the smoke to the system, activate this test, and if you see the ball jump, start to move down, you know that the command was issued. You just don't know if the system's sealed. That's where you're going to have to do further testing. It might go down to the bottom over a period of time and that fixed it, and you're tested it and you're done. Or it might hover like it is in this picture, and you know it worked, but the system's not sealed. Okay, so it's important to do that. Now, if you're doing this test and you take the scanner and you disconnect it, you back out of the test, whatever, with the key still on, that vent solenoid is still on. It is still heating up. The only way to do that is to turn the key off. And the way you can know you released it when you turn the key off is look at the ball in the smoke machine. And if it goes north to excessive flow, you know the vent solenoid opened up. That it's not sticking, it's open, the system is breathing again. Okay, so let's take a look at this one I did on a GM. This one does not have FTP readings on the global side, but it did have mode 8 and it worked well. So what I did on this car, you can see in the first couple, not venting, it's sitting out in the sun, it's building pressure. So what I did is I activated the vent solenoid through mode 8, just to make this point. Then to make the point that it doesn't release it, I exited the tool with the key on, never turned the key off, went over the OE side, and if you notice in the bottom slide right here, it is now, you can see not venting, it's venting, not venting, and venting. So the system is sealed, so it's starting to build up here. And what it's telling me is I could disconnect from the global side, go to the OE side without turning the key off, and the vent is still activated. Okay, so it's a little trick if you wanted to. If the manufacturer makes it a little hard to see the FTP, this is a little trick you could do. And I did the same thing on a Honda. I activated it on the global side, and then I turned around and went over the OE side to read my pressures and stuff. Okay, and then this last one on a Nissan, same type of thing. So Honda, Nissan, GM I used here, Ford I've used. Again, when it works well, but know your car, and this is where a little practice comes in to pay dividends. Okay, when you're blowing smoke, don't do anything to the car, leave the door open. If all goes well, and I'll show you the next slide, the two conditions. If you connect to smoke and the ball goes at top, that's good. That's telling you there's no restrictions in the system. And if you're just applying pressure without smoke, because you can separate them on some machines, it's just telling you there's no pressure buildup. If over time you see smoke coming out the back is what we would want you to do, then you know there's flow all the way through the system. Okay, if you apply it and the ball goes immediately to the bottom, you got a restriction somewhere in the system. It takes time to build this up, to make the ball drop. So give yourself time, make sure the ball drops to the bottom. Okay, so let's take a look at an open system, what you should see when you first hook up. System is open, vent is open, there's flow, no restrictions. Should be, if there was smoke in the system, it should be going out the back of the car in a little bit once there's enough in the car to flow through the system. Now, if you have a restriction, this is what it would look like. And we're going to look at this in an example here in a little bit. Notice what happens. If you put that to the car and you see that ball drop into the bottom right away, that tells you there's a restriction somewhere in the system. Okay? A couple of simple rules to follow to avoid trouble with your smoke machine. Get you out of trouble. Okay. Let's move on. So what I just mentioned here, I just repeated again to show you after the video. Let the ball rise, and if it sinks too quickly, you got a restriction. If you want to close it off, the vent, and you don't have access to the solenoid, scanner doesn't give you the option to do it, and that's possible on some of the older cars. You want to do it quickly while you're applying smoke. Find the fresh air tube from the canister and go ahead and pinch it off. Obviously, you're bypassing the vent solenoid, but at least you're seeing if the system integrity is tight. And at that point, you know that if it's tight there, the only thing you bypass is the vent solenoid, so it can help you focus on that particular part of the system. Okay? As far as pliers, this is one we use in California for our EVAP tester, for our smog inspections. It's nice. It reaches into places that you can't normally get to. A lot of them come with a long orange strap so you can leave it hanging out of the car so you don't leave it in the car when it leaves the shop. Works well. I do not recommend these. I'm going to show you a picture with one of these, but I don't recommend these because their clamping force on some of these hoses doesn't clamp tight enough to possibly seal a very small leak. So I say no on these. This is a fuel line hose clamp that OTC made. I've used those. The problem is sometimes they're not wide enough for some of the hoses we need. Vice grips, you say, oh, I can't use vice grips, I'm going to damage something. Well, first of all, rule of thumb is never clamp plastic lines. Okay, not a good idea because they don't go back to their original condition. But with rubber hoses, if you're thinking about this car you're working on, unless it's got super high miles and the hoses are brittle, you can use this vice grip, and it does a really nice job of clamping off the system so you can isolate the leak, and it won't cut the hose. You'd have to do it multiple times. When I was teaching this at college, and we taught it indirectly over 7,000 people using this method, I've never had anybody come back to me and say, oh, cut the hose. Because generally, you're only doing it once or twice. And at the college, we did this on some cars many times. Never cut the hose. Okay, so you want to get one of these? Great, they're cool. I'd recommend just an old-fashioned pair of vice grips. But remember, no clamping plastic lines. Now, if you're working on Toyotas, early Toyotas through 2004, 2005, depending on the vehicle, first of all, they tell you never apply more than 1 psi to the service port. 2, blow the smoke out the system. There you are. We got flow going through the system. We got smoke coming out. The problem with Toyota is they don't have a vent solenoid that you can just shut off. They do have vent solenoids on the later model, but there's a bypass to that. And I'll show you what that is. So when you work on a Toyota, that yellow line means this is where you clamp it off. This is where you do your smoke pressure testing. You clamp it off here. It tests everything forward. It's just like I did over here. Okay? Now, why do you do that? In the back of the charcoal canister, Toyota has what they call an auxiliary air valve, air drain valve. When the engine is off, that system is sealed. So in the previous webinars, I mentioned that when you're working with Toyota, you want to make sure that you look at the pressure reading, key on engine off, when it's been sitting or idling. And it's been off for a time. If it's had a chance to cool, it's probably going to be in a vacuum. If it's been idling a while, it's probably going to build a pressure if it's not purging. This valve is normally closed. That keeps the canister system and the EVAP system sealed. If you have a sealed container and any temperature change, it's going to expand and contract. When you go to fill up the car, it blows this open and pushes the fresh air out of the canister after it absorbs the vapor. If you're purging the engine with it running, it opens up to allow fresh air to be pulled in. So the reason we clamp this hose is when you smoke test the system, you are actually pushing this valve open, pushing the smoke out. So there is no way to seal the system unless you clamp this. So if everything was tight up to that point, there's a good possibility this air drain valve has gone bad and you need to replace the whole canister. Okay? And that's what it looks like. And I want to show you this little nipple right here. Very important. I'll show you in the next slide. There's the little check valve right up here. You push that open when you smoke test the system, so that's why smoke always comes out. So you clamp it right here. Now, when you go to Toyota, if you see this little rubber nipple, and what I do is I put a little rubber nipple on the end of my vice grip here, so I remember if I go to Toyota, I want to pull this hose off. I want to cap this off, and I still want to pinch this off, and I'm showing you here what happens. These are the hose clamps I don't like. This is not a tight clamp here. But the reason you clamp this, take this off and cap it is, this is the top side of the FTP. It's the atmospheric side of the FTP. If that FTP is leaking, I'll see smoke coming out of here. If I leave it hooked up, the system just goes in a loop, the pressure builds, and if there's any leak, it'll leak internally, and the pressure sensor will hold the pressure because the system is sealed. So what I do is, 2 things on these Toyotas is, there's a nipple here, clamp it off, I remove it, put a cap on it, and then clamp it off over here on the yellow line. Now you're ready to smoke test the Toyota. Again, a lot of 2005s and older still out there. They don't have a pump system. This is the most common system from 2000 to about 2004. Okay? And here's that valve again. Just reminding you, this is what makes it a sealed system. So in your diagnosis of Toyota, look at your FTP. If the car's been sitting overnight, that chances are that thing is going to be in a vacuum. If it's been exposed to the heat and it's warm, then it's going to be in a pressure. If it's running, it may not because it's going to be purging through here and drawing in fresh air. And when you fill up the system, it blows this out and forces the air out of here. So little trick on that one. Okay, pressure testing with a leak present. With the vent open, apply smoke to the system till it comes out the fresh air hose. That's what I was showing you here. You want to see this right here on all cars. Okay? Now, when you get to that point, if smoke does not come out, it could be that you're 100% liquid in the tank. It's harder to get it out because there's no expansion in there. So make sure the fuel level's down a little bit. There could be a bypass solenoid in the middle of the system blocking it, like Toyota or Honda. The blockage might be present somewhere else in the system, and the leak detection machine may not be working right. Never doubt that your machine could give you a problem. So if you're going to apply light to it, this is one of the ways you can do it. Most machines come with some kind of white light, so at least you can see smoke. There's the UV dye using the light, so you can see, highlight the point. But I want to emphasize that doesn't always happen that way. Sometimes the way they liquefy, they don't get the smoke. They'll actually turn into droplets of liquid and things will be wet. And I'll show you that in a couple here. Now, I want to show you this one because they went to flow meters on some of these machines. They went to them for a reason. The smaller the leak, we want to reduce the flow. By pushing that fluid with the dye in it, if it's a very small leak, it's a very possibility that we could plug it up. So on this knob, if I was on a small leak, I want to get down in these small leaks right here, 20, 30, I'd move it down to the lower flow. Now you notice it says 20, that was for future use, we never hit it. I would reduce it. Snap-on made a machine that actually adjusts for the flow, and as you'll see in this little video, it pulses. So let's walk through this one real quick.
Did you know 8 out of the top 10 emissions DTCs can be diagnosed with smoke detection technology?
And that's still very common today.
Whoa. Introducing the Smart Smoke Evaporative Emissions Tester.
This is an older machine. We happen to have one. Worked well, but it was not commonplace. But let's see what some of the features that you can do with a smoke machine.
Smokes and tests. Smart Smoke can be powered by any Snap-on 14 or 18 volt power tool battery or off the vehicle battery. It accepts shop air or any inert gas, OEM specified nitrogen or CO2. And it comes with a step-saving wireless remote control. Switch to low flow for better isolating a leak.
There you go. That's for the small leaks.
Ultra Trace UV dye. Measure vacuum or pressure in inches of water column. Or smoke from 2 locations at the same time. Smart Smoke detects many types of leaks. 1 unit, many ways of generating profit. And it's all backed by a 3-year warranty.
So remember, with Snap-on or any smoke machine, you can use it for other things. Now, here's the white light. Here's what happens when the dye puddles. Okay? You can see the greenish color. That's basically a leak at that point. The smoke isn't there, but the way the leak is, the liquid is coming out as a liquid. So you got to be aware of that. Okay? You don't always see the smoke. Now, here's another way you can do it. Hot soapy water. Take a look at the hot soapy water at this point on this gas tank, this Jeep Wrangler, kind of rusted out. And as you spray it with hot soapy water, look at what happens. You got a pretty good idea where your leak is. Very simple, inexpensive, and quick. Okay? Smoke machines, I told you about the flow meter. Always have a flow meter. Always, if you can get it with a flow reduction, that's even better. And most of your machines, you can attach a CO2 cartridge to it, so you can be mobile with it if you need to. So keep that in mind. This is an old tried and true. I don't know how many people still have a sniffer. If you're in California or smog tech, you probably got one. But not everybody does if they're only doing inspections. But if you're doing repairs, you definitely have a smog. Get one with a stinger probe, and that's what they all used to have. That's a great little probe up there to be able to put above gas tanks and in hard to reach places. And if you're pressure testing, if you notice the hydrocarbons are rising, that's an indication there's a leak up in that area somewhere. Nice little trick to do before pulling down any gas tanks. So again, didn't have to spend anything. Bottle with soap and water. Sniffer, if you have one, you're good to go. There's one other machine out there that does a good job. They do it with CO2. Let's take a look at this from ATS. See if it's going to run. I was having a problem with the link earlier. There we go.
Bullseye leak detector picks up where other leak detectors leave off. The Bullseye leak detection system accurately pinpoints all leaks, big or small, on any sealed system. Hit the bullseye every time on challenging evaporative emission system leaks. Traditional smoke testing can be a challenge. Either the smoke escapes in such a volume that the source is hard to pinpoint, or the leak is so small the smoke is undetectable. Yet another problem for smoke is it is an oil base that is heated into a vapor. This vapor is made up of hydrocarbons. In chemistry, likes break down likes. In other words, the gasoline being a hydrocarbon base will break down the smoke. Thus, no smoke will be present at the leak site. And yet another challenge can be sealing the EVAP system for testing. With the Bullseye Smart Control, you can quickly connect to the EVAP vent and purge solenoids to seal the EVAP system and prepare it for leak testing. Once the Smart Control is connected, actuate the solenoids by pressing on or off. Alternatively, you can plug the EVAP vent line using plastic plugs. Once the system is sealed, connect the EVAP test port adapter and prepare the low-pressure CO2 tank regulator. If the gauge needle is in the green, it indicates there is no leak at this time. If the needle is in the yellow, you have a leak that is about 5 thousandths to 15 thousandths in leak size. If the needle is in the light orange, you have a leak that is 15 thousandths to 25 thousandths in leak size. If the needle is in the orange, you have a leak that is about 25 thousandths to 40 thousandths in leak size. If the needle is in the red, you have a leak that is greater than 40 thousandths in leak size. Using the electronic leak detector, slowly sample the area suspected with the leak. The leak detector LED will illuminate as you move toward the leak. The frequency of beeping and the LEDs illuminated will increase as you move toward the source. Once the base location is identified, use the leak seeker solution to hit the bullseye. Spray the suspected area with the leak. The solution will change from red to yellow at the leak site. Bubbles may also be present on larger leaks. We hit the bullseye on this one. A leak at the fuel filler neck was quickly and accurately identified. Hit the bullseye every time when searching for sealed system leaks on air conditioning systems, cooling systems including head gasket leaks, wheel and tire, evaporative emission systems, air ride suspensions, engine oil leaks, and more.
Okay, so that's another option available to you. Not saying you have to have it. I happen to have one, but I would tell you that, let's see, we locked up there. Let me get out of there a second for some reason. Let me go back. Know why it locked up. Let's try that again. There we go. Okay, let's look at this case study. What we thought should have been a simple problem. We did our visual inspection, came in with a large leak code. You can see the crack there at the canister, the rear of the car. So we did our due diligence and we blew smoke through there. And as soon as we hooked up the smoke, the ball dropped. Nothing came out the canister. So we worked our way along the system. There's what should have happened. Here's what happened to that vehicle. Immediately to the bottom. So we got a restriction. You can use this to clamp off, but it didn't do any good because everything was forward. But I just want to show you that if you're going to isolate, you clamp. But in this case, we didn't need to. So we pulled the hose down at the canister, and this was what was inside the canister. Filled with chocolate or dark granulated charcoal. Someone either overfilled this or this thing was taken in water somehow. And some of the older Nissans, the vent tube used to stick downward. So if it ever went into high water or it went into launch, it was a truck, maybe launched a boat, got down in the water, anything liquid, but especially gasoline gets in that canister, that's what happened. This thing had plug lines all the way forward to the front of the car. So the only way he could do this was either bypass with a rubber line all the way or put some new metal lines on it. Okay, so simple isn't always simple. Do a good visual inspection and think the system out. Okay, let's get through the last few. Okay, when you're working with the system, here's what you want to remember. The car isn't repaired until the ball is at the bottom and stays there. So this was a 13 Honda Odyssey that we had. We were leak testing it, and we noticed as we're watching this for a minute, the ball kept bouncing up and down, up and down, up and down. We know we don't have it fixed. So we're going through things, we're checking it, and the last thing we went to was the gas cap. And looking at the gas cap here. Somehow this thing was, when you closed it up tight, it was small enough to trip the ball, but at the same time, it could be sealed and unsealed. So when you're doing this, the smallest little cracks can add up to a problem. So if the ball isn't at the bottom, the car isn't repaired, don't send it out the door. It'll be coming back. Okay, the last few things on the check with the filler neck, don't forget that. Those filler necks take a lot of beating. Every time you put a nozzle in the car, it's being tipped down, it's being pressurized, being leaned on by the by the fill pump. Take a look at the filler neck, because sometimes your problem's right there. It's not the cap, but the filler neck is distorted. Okay, that should bring us to the end of the day. There's my email if you need to get a hold of me. I'm here as a resource for you. Don't be afraid to reach out. There's my website. I thank Delphi for allowing me to do this series of EVAP webinars. I hope they were helpful to the people that were with me all through all of them. But for you that may have just joined today, I hope you got something out of it. If you need more information, reach out to my website, or you can reach out to me. So I thank you, and look forward to seeing you again sometime in the future. Take care and have a great day.